So, hello, just give me a yeah. Hello everyone. Welcome to Meet 62. No, welcome to Meet 63. And basically, what we are going to discuss today, we are going to discuss about the machine learning algorithms. We are going to start with that. And before that, right, I just want you to uh, just understand that basically what is machine learning and what problems we are going to solve it basically, right? So if we will just look into, and when I discuss about machine learning, okay, and when I simply write here machine learning, just take the short form of that, ML, okay. And if I will write ML, so basically what's there in ML, okay, if we will just understand, so basically there is supervised learning. And again, the another part of machine learning is unsupervised learning. Just pardon me with my writing. Okay. So basically, one is supervised and second one is unsupervised learning. Okay. And basically, in supervised learning, what problem we are going to solve? Okay. What problem we are going to solve in supervised learning? Okay. So there are generally two problems which we solve in supervised learning. Is first is regression. First is regression, and the second one is classification. And the second one is classification. Okay. And when you will understand it more, okay, more in the sense, like, what do you mean by regression? What do you understand by regression? What comes under regression, right? So basically, what comes under regression is the continuous data, continuous data. We deal with continuous data in regression problem. And in classification, which type of data we deal? We deal with discrete one. We deal with discrete one. We deal with discrete data, right? And again, in continuous data, how it will be going to classify into? There are two types of data in continuous. One, it is called interval data. One, it's called interval data. And what's the second one called? Second one, it's called the ratio data. Second one, what it's called? It's called ratio data, right? And in data which is in discrete form, what's the first name which is called? When you will further categorize it, first we name it as nominal data. What do we call? Nominal data, right? And what's the second version of that? Means the second is ordinal data. Ordinal. Okay. So basically, like these things, if we just dive into these things, so you have to understand the basics behind it. Whenever we are learning ML, right? Whenever we are learning ML, so the most important thing what we are going to see that, okay, uh, what type of data it is, right? For example, it is having the interval data, it is having the ratio data. Okay, so that data will be in the continuous form, right? And whenever the data it is in continuous form, we will apply here the regression model. We will apply here in regression model. And again, in regression, what it comes under supervised. And in regression, your both independent and dependent features are given to you, right? What happens with regression? What happens with regression? Both input and output. Pardon my words, it's not basically the regression. It's basically the supervised learning. In supervised learning, both input and output variables are given to us, right? The dependent and independent features, right? It's given to us. What is the output? Output here is basically called our dependent feature, right? What is output? Output is dependent. Output, its dependent feature, right? And what's input feature called? Why it's happening? I don't understand it. Yeah. So input, its independent feature, independent. Okay. It is basically the independent feature. Hmm. So now you have understood, like in ML, what are the dependent features, what are the independent features, and what is supervised learning, what is unsupervised learning, right? And in supervised learning, what problem we are going to solve? Obviously, it's a regression problem. What type of uh, data it holds? It holds continuous data. Okay, so these all things we have discussed here till now, right? Now, now what we will discuss more into like the first ML, machine learning algorithm. What will be the first ML we will be discussing into, right? So the very first model which we will be discussing into, it's is linear regression, right? The very first model, it's linear regression. Again, I want you to here understand what do you mean by the word itself linear. What is linear? Linear basically defines as something which is in a straight line, right? Something which is in straight line. Okay. So for example, this is a line, right? This is a line. This is my x-axis. This is my y-axis, right? This is the line. And what do you understand by the linear line? Okay. So in linear regression, what it does, it depicts the best fit line. This line only we are going to discuss. This line basically, this line is linear regression. This line itself, the model, the linear regression model, which it's going to prepare, it's the best fit line only, right? And one more thing, which you guys have understand, right? So, not here, if I will just talking about 11, 12 maths, right? And we just, sorry, dive more deep into the some mathematics institution of it, right? So basically, what's the maths behind it? How this line we are going to find, right? So how the line we are going to find, we are going to write with the help of y is equal to mx plus c, mx plus c. So basically, this is the line. Instead of y, what I will do, I will write here y hat. Okay, I will write here y hat. Why y hat? Because these are the predicted lines. Sorry, these are my predicted points. Okay, so basically these points are my predicted points, right? So these are all my predicted points, and these predicted points is being denoted with the help of y hat is equal to mx plus c, right? And when we will just dive into some deep learning, if you would understand the deep learning concepts as well. So basically, if you are learning machine learning, right? So you should understand it in the most standard way. Standard way, like in the terms of industry, or we can say that if we are learning one thing, so that we should learn something in such a way that we can able to understand it in a broader concept, right? So how we will understand it in the broader concept, like, so for example, instead of y hat, what I will do, I will write here h theta. Okay, so basically it will be my h theta, and h theta of x is equal to my theta 0 plus theta of 1, and here x1, right? Here it will be x1. So what is basically this x1? What is basically this x1, right? So this x1 is the same data point which we are taking into consideration, right? This is the same data point x1 which we are taking into consideration, the first point, right? And if you want to write it into for all the multiple values, for all the multiple points, so what we will do, we will simply write here h theta of xy plus, we will be writing, we will be writing theta 2 x2. Okay, so similarly, if we will just go ahead, where, till the value of n. So a time will come that there are multiple points, and in multiple points there will be theta n, my theta value will be n. Okay, and what will be my x value? Similarly, my x value will be here n. Okay, so this is for multiple data points. When we are taking into consideration for multiple data points, then we are writing like this. Okay, and now what we are going to do, right? For example, this is our best fit line. We have considered this our best fit line. and this is only our this something which is in green, it is my predicted point, and something which is in blue, as you can see here, these are my actual data points, right? So what is this? This is my actual day data points. So how we are going to find it? What we are going to do it in linear regression, right? We are simply doing what we will be doing. We will be subtracting our predicted value and actual value, right? Then only we can get the accuracy. If we talk about accuracy, right? So for example, what we do in linear regression, right? For example, our model has predicted here till here, right? And if we have one point here, right? And if we will extend this line, if we will extend this line, right? So somewhere or the other here itself, you can be able to see my model would be able to predict that, okay, for this point, this will be the value of, sorry, one thing, this will be X, this will be Y. My mistake. Okay. Yeah. So this was X and this was Y. Yeah. Right. So, for example, this is my, what you can say, area, right? Area, right? And this is my sales. This is my sales. This is my sales, right? So basically in this particular area, what will be my sales, right? So we are predicting that value. So again, how we are going to predict it? We are going to predict it with the help of subtracting our actual value minus predicted value, or predicted value minus actual value, right? So how we can write that, right? So we can simply write that, uh, if we are going to find the error, right? If we are going to find the error, right? So what is error basically? Error we can find by our predicted value minus actual value, right? This is my actual value. This is my actual value predicted minus actual value. So what is the predicted value? What is the predicted value? Predicted value is the same, which is h theta, right? And it's the same, which is y hat, right? So what we can do, we can write it like this: y hat, y hat minus y, right? Or in another terms, what we can write? We can write my x theta of x minus y, or we can write theta 0 plus theta 1 of x1 minus y, right? So there are different terms related to it. Different terms mean different ways how we can write it, right? This is our first way. This is our first way. This this is our second way. What is this? This is our again third way. Third way. And why I am discussing these things, right? Because in various books, in various textbooks, you can see the different notation of calculating the error of, and basically what is this called? What is this called? This is called in terms of hypothesis. Okay. So basically, what is hypothesis? If we talk about what is hypothesis, right? So basically, initially what we have our test data, we have our test data, right? And the test data, what we do, we pass it through our model. This is our model. And again, this model, we pass it through hypothesis, right? This is our hypothesis, right? So basically, hypothesis, what is meant by hypothesis, right? So basically, if you have created a model, right? You have passed a test day data set or any data set, you have passed it, you have made a model, right? Now, again, with the help of hyperparameter tuning, right? You will test your model, right? So here, again, after making hypothesis, what we will do? We will do hypothesis testing as well, right? We will do hypothesis testing as well. So in generic term, okay, if I will just open here, okay, I am opening here this, and I will just write here hypothesis, right? Right. See, a hypothesis is the proposed explanation for phenomenon, often formulated as a stable statement that predicts between variables. Okay, so basically, what we are going to do, we are going to predict the relationship between the variables as well, right? So for that, we need to create an hypothesis out of that model, right? And again, with hypothesis testing, what we are going to do, with the help of hypothesis testing, we are going to test that model, right? Now, I will just discuss about that how this formula works, how this hypothesis, and how these all things, these terminologies work with respect to linear regression, right? So the very first thing which we have understood in linear regression, what we are going to do, we are going to create the best fit line. And again, how is that best fit line denoted by? It generally y hat is equal to mx plus c. Or in the terms of hypothesis, in the terms of hypothesis, how you can write h theta of x is equal to theta naught plus theta 1 x1. And generally for several points till theta n plus xn, right? We have discussed all things, right? Now, what we are going to do, for example, uh, let me draw the graph again. And here, what you can see, this is my y-axis and this is my x-axis, right? And we are going to discuss about the cost function, right? The cost function, the very first function, which is cost function. cost function. So just focus here. It's like what I'm going to discuss. I'm going to just explain you in a simple terms what is meant by cost function, right? What is meant by cost function? So, for example, this was my best fit line, and say I have here one data point. Here, this is my what you can say. This is my actual data points, right? This is my actual data points, and these are my predicted data points. These are my predicted data points, and what we are calculating basically with the donation when we denote with h theta, h theta of x, when we write it like this, of theta 0 plus theta 1, theta 1 x1. So what it is basically, it is the same thing when we are writing about slope. We are finding the slope, and what is this? This is the intercept. This is the intercept. This is the intercept. And what is this? Theta 1 is basically our slope. And this is the basically line. This is the only hypothesis which we are talking about. Now, if we just calculate the errors, when we just discussed about the error, so what is basically error? The distance between these 2 points. The distance. The least the distance it will be, the more accurate our result will be, the more efficient our model will be. Okay. So I have told you how we can calculate the distance. Okay. So the very first thing which I have discussed here is with respect to error, when we just write about h theta of x minus y. Instead of h theta of x, what you can write? You can write here y hat. Y hat is equal to, sorry, y hat minus y. And what is this y hat? This y hat is same h theta of x, which is mx plus c, right? So we were discussing about that. The mx plus c is there, right? And what we do, for example, if we are subtracting the distance, right? So it might happen that our predicted value, you can see here, it's more here, and the value of x is less. Again, here the value of x is more, our predicted value is less. So it might happen that the distance will come in negative. So we are doing it square. Why we are doing it square? We are doing it square because our distance will come in negative, and to make it positive, we are doing it square, right? And what we are doing, one thing we are doing here, summation as well, sum of all distance, this distance, this distance, this distance, this, everything we are going to do. Okay. And from where? From 1 till n, right? So what we are going to do, to make it an average, we are going to divide it by n. And whenever, just understand the derivative which we learn in class 11. Okay, for example, if we have to differentiate x square with respect to x, okay, whenever we are differentiating, so how we are writing it? We are writing dy dx, dy dx into x square. So basically we are differentiating this, and what this value will come? This value will come to x. Okay. So these two, somewhere or the other, if we are just understand the basics of differentiation, these two, when we will differentiate the value, it will come here, right? After differentiation, somewhere or the other, it will come here. So we will be divided by 2. So we will be dividing it by 2. Why? Because we are differentiating. What we are differentiating? What is a slope? Okay. What is a slope? If you are going to find it, what is the slope of this? So basically, it's nothing but the angle in which the line is meeting the x-axis and y-axis, right? So basically, this is the slope. This is the angle which we are talking about. Okay, what is a slope? This is a slope, right? And basically, this is the angle which we are talking about. So what happens? What is dy dx? Dy, the rate of change of y. Rate of change of y with respect to x. We can call it a slope because a unit change in x, how it depends upon y. A unit change from here till here, if you are changing the values, so how the slope is changing, right? So basically, that we are understanding here, that we are changing here, right? So everything that depends upon the slope which we are finding it, and with the help of the slope itself, we are going to find the best fit line. So you can again here understand, right, that this the function which we have calculated, this total term, okay, I will circle this total term, this thing is known as cost function. This whole thing is known as cost function. And basically, in linear regression, what we are going to do? We are minimizing the error. We are taking the mean of it. You can see here we are taking the mean of it. So we can also denote it by mean squared error, right? And what's the difference between this? If if we are calculating the difference between predicted value and actual value, what is called? It is called sum of residuals, right? SSR. So there are various terminologies which is there and the terms is there. You just have to understand it so that you can just explain it to the interviewer. If interviewer asked, okay, what in linear regression, for example, the in cost function, what you are basically going to do that. Okay, so this sum of the residuals, what is that? It's the actual minus predicted point. In a generic term, you can call it this is an error. But again, what is that? That is sum of residuals. And this is our cost function. And how we have derived the cost function? Again, I'm repeating that. Y minus y hat. Y minus y hat is nothing but this thing, our sum of residuals, the distance between that point. And what is y hat? Y hat is nothing but h theta of x. That is similarly the y hat here, which we are going to discuss about. Okay. And why we are doing it square? We are doing it square but because we don't have to take the negative value, because square of anything will be positive, positive square positive, negative square negative, and we are dividing it by again 2 here. Why? Because we are differentiating. How we are differentiating? The slope itself, the rate of change of y with respect to x, the rate of change of y dy by dx, the rate of change of y with respect to x, that we are going to discuss about. So how it is affecting the rate of change of x square. Okay, in our x, if we are changing the value by its square, So how it will change in y? It will change in y by 2x. So why we have put here 2? We have put here 2 because at the end we are going to differentiate this value. We are going to differentiate the different this value, and to substitute it with this 2 and this 2, I have basically written here by 2. And why n? Because we are taking the mean of it. So little mean squared error as well, right? So for today, I'm stopping here. Tomorrow I will just discuss about the graphs of it, how the graphs will look like. So till then, you just keep watching. And if you have any feedbacks, you can just suggest me whatever feedbacks is needed, that whether you are understanding it good or something is needed to be changed, something is needed to be added, right? So that thing. And again, you have to subscribe it. Why you won't subscribe and it will affect? Why? Because you will not get the terms. Means like, for example, I'm going to start a new playlist for AI project, which previously I have done. Again, one new project I'm going to do that. So you will not get the notification of that. So till then, you just keep practicing it. See you in my next video. Till then, goodbye. Take care. Jai Hind.